Okay, class, today we're going to start talking about symmetry, and I've alluded to it in other videos so far in this section, I guess in the first video. So we're going to really talk about it today, and that's what the lesson's on, the symmetry of polar equations. So there are three ways for something to be symmetric in polar equations. The first one is symmetric to the line theta equals pi over 2, which is, let me make this fatter, is this line right here. Okay, symmetric to that line. That's theta equals pi over 2. Then it can be symmetric to the polar axis, which is this line right here, your usual x-axis, but we call that the polar. So remember, you don't call this the y-axis, you call it theta equals pi over 2. And this one you call the polar axis, not x. And symmetric to the pole, you call that, it would be the same as being symmetric to the origin on a coordinate plane. So those are the three types of symmetry that you have for these types of equations. Let's move on now. There are ways to test symmetry, and you basically have to memorize this, okay? So if you want to test whether it's symmetric to the line theta equals pi over 2, you replace r theta with negative r negative theta. And I'm going to go do these first little groups. So you switch both r and theta with negative. If you want it symmetric, to see if it's symmetric to the polar axis, you just switch the theta to be negative. Okay, I'm over here. Right here. Okay, and then if you want to see if it's symmetric to the pole, you change it, just the r to be negative. You go from r theta and change negative r to theta. Now, the second group that you test is because you can go backwards. And so I don't really have any problem remembering that these go this way. First both, then the theta, then the r. But this group is harder for me to remember. But these are because we need to be able to go backwards and test that way too. So when you're testing for symmetry of theta equals pi over 2, you test for both negative r and theta, or you also have to do this test. Keep r the same, and then change theta to pi minus theta. And I'll show you when we start doing the problems what I mean. And then the second one, you change r to negative r and still do pi minus theta. And then the third one, again, symmetric about the pole, you change to keep r, and do pi plus theta. So what we are going to be doing in these first tests, these first problems, is test all three of these. So it looks like quite a bit of work, and it is. It takes time. So in your notes, you need to slowly work these out. Okay, so when I turn the page, don't freak. I've already written out the notes. So here we go. Okay, here's your first example. You have this question, r equals 2 plus 2 cosine theta, and they want you to decide whether it's whether it's symmetric to the theta equals pi over 2 line, the polar axis, or the pole. So how we do this is we start with, I put a number 1. Let's check whether it's symmetric to theta equals pi over 2. So the first thing we do, it's the first test for this one, change r and change to negative r and theta to negative theta. So here's me saying negative r equals 2 plus cosine negative theta. And so negative r, and you end up, remember the identity that says 2 cosine negative theta equals 2 cosine theta, so you end up losing the negative there. So is that the same as the original problem? No, it is not. So that's a no for this test. Okay, moving on to this test is the second, this is the OR test for theta equals pi over 2. I keep r, and I change theta to pi minus theta. So here's me putting it in r, 2 plus 2 cosine pi minus theta. Now, this is where you need to pay attention. This is your angle addition or subtraction identity. And you remember, cosine angle addition is cosine cosine, and then because that's a minus, that would be a plus. So you have to split this into 2. So you get cosine pi cosine theta plus sine pi sine theta. Now look what happens. Cosine pi is -1. So that would be a -1, and then it would be cosine theta. And sine pi is 0, so there would be your 0. So you end up with 2 plus -2 cosine theta. So does 2 minus 2 cosine theta match the original problem? This is 2 minus 2 cosine theta. And the answer is no, it does not. So we know that it's not symmetric to theta equals pi over 2, so we can cross that one off. Now, going on to the second test, we decide whether it's polar, symmetric to the polar axis. So we change theta to negative theta. So putting negative theta in, you get r equals 2 plus cosine, and stick the negative theta in. And sure enough, remember, because of that identity, you just get a positive back again. So definitely that matches that. So this is a yes. And I didn't even have to do the or part. It is symmetric to the polar axis. Going on to see if it's symmetric to the pole. Now, see, you have to do all three because it could be a combination of 2 different ones. It's not just like, oh, okay, so it's symmetric against the polar axis. It could also be symmetric against the pole. It can have 2 or 3 different, 1, 2, or 3 different symmetries. So in the pole one, remember, you first start with changing -r and not theta. And definitely that won't ever come out to be the same, so no on that. If you were to solve this for r, you would get r equals -2 minus 2 cosine theta. So that's a no. Now, the or part said take r, keep it positive, but do theta plus pi. So here's me writing it out. R equals 2 plus 2 cosine pi plus theta. So now I have to use the identity property, the angle addition property. So I get 2 plus 2 cosine pi cosine theta minus sine pi sine theta. So working that out, it's 2 plus, and this would be -1, so that would be a -2 cosine theta minus 0. So you get r equals 2 minus 2 cosine theta, and you were supposed to have 2 plus, so this one's a no. So that's how you do it, testing all the equation for all 3 types of symmetry. So we'll do a few more examples on the next videos.